Hi guys, today we're going to learn about the law of cosines. And as you can see from our first slide, the law of cosines is used to calculate the angle or a side for obtuse and acute triangles. And we'll look at how to determine that in the equation that the law of cosine represents coming up. Now in our previous unit we used sine, cosine, tangent to calculate angles and sides of right triangles. Now, SOHCAHTOA helps us remember the relationship among sine, cosine, and tangent as detailed below. But what do we do when we're not given a right triangle? How do we figure out the sides and the angles for triangles that are not right triangles? And as you can see, what we're going to do is we're going to use the law of cosines to calculate the angles and sides when it's not a right triangle, and that would be triangles that are acute or obtuse triangles. Now, below are examples of acute triangles, and as you probably already know, an acute triangle is a triangle with three acute angles. An acute angle is less than 90 degrees, but greater than 0 degrees. And as you can see that every triangle, the three internal angles add up to 180 degrees. That's with every triangle. And below are examples of obtuse triangles. An obtuse triangle is a triangle with one obtuse angle, which is greater than 90 degrees, but less than 180 degrees, and two acute angles. And as you can sense, and as you probably already know, there is no way you could have two obtuse angles in one triangle, since the three angles in a triangle, in every triangle, add up to 180 degrees. Now the law of cosines, as you can see here, is used to calculate the third side of a triangle when we know two sides of a triangle and the angle between them, and it's also used to determine the angle of a triangle when we know the lengths of three sides of that triangle. The law of cosines has capital and lowercase letters, and those are critically important to understand. The lowercase a, b, c represent the sides of the triangle, opposite the uppercase a, b, and c, which represent the corresponding angles. Now the law of cosines, which is c squared is equal to a squared plus b squared minus 2 times a times b times the cosine of c, capital C, resembles the Pythagorean theorem, c squared is equal to a squared plus b squared. In fact, the law of cosines is identical to the Pythagorean theorem if we're looking at a cosine of 90 degrees, because a cosine of 90 degrees is equal to 0. And as you can see, we did it right here with the law of cosines. We put the cosine of 90 degrees, which is 0, and that gives you the Pythagorean theorem. As a result, the law of cosines is typically used for acute and obtuse triangles, but not for right triangles. For right triangles, you'd use SOHCAHTOA, you use the Pythagorean theorem. You wouldn't really want to use the law of cosines, but you could use it, but typically, and honestly, you would not use that. Now, before you start the calculations, make sure your calculator is in degree mode. For a T84 Plus calculator, which we have here in class, we have to press the mode key, use the arrow keys to highlight the degree, and then press the enter key to ensure that we're on the degree mode. It's important to note that for the default for our T84 Plus calculators is rating mode, as detailed in the screenshot below. So be very, very careful to make sure that you're in degree mode before working on any law of cosine questions, because if you're in radian mode and you start your questions, every question will probably be wrong. So make sure you're in degree mode. For our example 1, in the below triangle, side AB is 100, side BC is 66, and angle ABC is 25 degrees. What is the measurement of side AC? Well, we know side AC is a side, therefore it's lowercase, and we make it, in this case, C. So according to our equation, c squared is equal to a squared plus b squared minus 2ab times cosine of capital C. Well, it doesn't matter what lowercase a and b is as long as you are consistent with it. In this case, we said lowercase a is 100, lowercase b is 66. We plugged into our equation. And capital C is going to be the angle, which is 25 degrees. Doing our calculations, we get the cosine at 25 degrees is 0.9063. We're in degree mode, of course. We get c squared is equal to 2,392.84. We square root both sides, and we get c is equal to 48.92. As you can see, there it is. Example 2, in the below diagram, side KM is 38 inches, side MN is 40 inches, and angle KMN, where are you? KMN, right here, is 93 degrees. What is the measurement of side KN, which is here, also denoted by lowercase m? Well, using our law of cosines, we're trying to figure out, calculate the side, which is lowercase. We're going to do lowercase c. A and B, again, it doesn't matter which one is which, as long as you're consistent. We said A is 38 and B is 40, which you can see. We plug it into our equation. 93 is a capital C because it's the angle. We do our calculations to determine that c squared is equal to 3,203.1. We square root both to get what c is, which is our side, and we get 56.6 inches. And there it would be, 56.6 inches for c. Now again, students can get confused on the notion, well wait, this is a lowercase c, that's a lowercase m. Just remember in your equation, the c, lowercase c, is your side, which is corresponding to the uppercase c. In this case, you can consider this as uppercase c and lowercase c for our equation, but you can see for this problem, m is going to be the side opposite that angle. So I don't want you to get confused. Just remember lowercase c is a side and uppercase c is the angle, and they correspond to one another. Now, does our work make sense? Does it make sense? And how do we determine if it makes sense? Well, we determined that this side m was 56.6 inches, and since KMN is the largest angle in this triangle, because there's no way you can have two obtuse angles in a triangle, because a triangle is only 180 degrees, the sum of all the three angles, the corresponding side, lowercase m, must be the largest side. And it is. As a result, our answer makes sense. Now remember, the longest side in a triangle is always opposite the largest angle, and the shortest side is always opposite the smallest angle. So if you're looking at this triangle, you would say, well, this is the largest angle opposite the largest side, and this would be the smallest angle opposite the smallest side, and this would be the guy in the middle angle opposite the middle side, if that makes sense to you. Again, largest angle, largest side. Most likely, you can see here, this would be the smallest angle, the smallest side, and this would have to be the guy in the middle angle, middle side. So given the below triangle, for example, 3, with side AB is going to be 3, BC is going to be 4, and AC is going to be 2, what is the measurement of ABC? What is this? Now, this is going to be opposite the smallest side. So it's going to be, relatively small angle. We do our work, c squared, which is the side, lowercase c. It doesn't matter what a and b are, lowercase a and b, as long as you're consistent. We said a, lowercase a was 3, lowercase b was 4, we were consistent. We do our math. We're trying to figure out the angle, that's capital C. We need to do the inverse to get what that is, and we get capital C is equal to 28.96 degrees. So this angle right here, angle ABC, is 28.96 degrees. Example 4, let's continue working with the triangle from example 3, and here it is. Now we calculate angle ABC was 28.96 degrees. What is the measurement of angle BAC? Now that would be opposite the largest side, so it's going to be the largest angle. When we do it, we're looking at our side, so you can see that c squared is going to be opposite here because it corresponds to angle C, which we're looking here, BAC, so that's our angle corresponding to that side. So that would be our 4 squared. Now it doesn't matter what A and B are, lowercase a and b, as long as you're consistent. And we said in this case, lowercase a is 3 and lowercase b is 4, lowercase b is 2, lowercase b is 2. And there we go, 3 squared and 2 squared. We are consistent with our math. We go through the calculations, and we get the inverse of cosine C, capital, because we want the angle, and we got that. And the inverse of that would be 104.48 degrees. Now, what is 104.48 degrees? That's going to be BAC. It's going to be this guy right here. And it makes sense because it's opposite the largest side, so it'd be the largest angle. Now, example 5, we'll continue with the triangle from the previous example here. And we calculated angle ABC. ABC was the smallest angle. It was 28.96 degrees. There it was, right here, 28.96 degrees. Angle BAC, BAC is going to be 104.48 degrees. And since there are 180 degrees in every triangle, we can calculate angle ACB, ACB right here, which should be in the middle of 28.96 degrees and 104.48 degrees. It's got to be bigger than this, but smaller than this, and it is, which is good. And it shows our corresponding relationship does work. Smallest side, smallest angle. Largest side, largest angle. It's going to be middle angle, middle side. Checking our work. Well, since side BC is the largest side, its corresponding angle, BAC, should be the largest angle, and it is. Since side AB is the middle value, its corresponding angle, BCA, should be in the middle, and it is. And it should be smaller than angle BAC, but larger than angle ABC. And lastly, since AC is the smallest side, its corresponding angle, ABC, should be the smallest angle as well. And it is. And you can see it all works out perfectly. And these three angles add up to 180 degrees, which is the sum of the internal three angles in a triangle. Now, tomorrow in class, we're going to review the following two questions in detail. Please do your best to complete these problems prior to arriving in class. And you can see problem 1, in the below triangle, side AB is 42, side AC is 21, angle BAC is 38 degrees. What is the length of side BC? Now again, you can see corresponding angles. This would be the corresponding angle. This would be the corresponding side. And here, problem 2, in the below triangle, side AB is 7, side BC is 8, and side AC is 6. Was a measurement of side angle CAB. Now we can kind of have a sense it's opposite the largest side, so it's going to be the largest angle, CAB. So thank you guys. I'll also email you copies of this presentation so you can have it for your own notes to look through whenever you wish. Thank you guys. See you tomorrow.